We're going to look at the chi-square distribution. To do that, we can just use Excel. Same thing with the t-distribution, we just need to specify a normalized statistic x. And since it's normalized, we can assume that we can use -3 and we can increment that by -0.5. We can just drag this until we reach +3 again. Alright, there we go. And if you wanted to do the distribution itself, you just need to press Y and cosine chi. There you go, and it would show the chi-square distribution. And again, it requires you to do an x, the statistic x, the degrees of freedom. So for now, let's try to use 1 degrees of freedom, and cumulative false, because we just wanted to see the distribution itself, not the probability accumulation. Alright, let's just drag this down. I will do another chi-square here. Let's call this one y1 for 1 degrees of freedom. And I will do another chi-square here with 2 degrees of freedom. And let's compare. So chi-square distribution, the x values, degrees of freedom 2, and cumulative 4. Let's press enter and double click. Notice that the negative doesn't have any value. We'll talk about that later. But for now, let's do another chi-square, maybe 4 degrees of freedom now. So chi-square, the x value, parentheses 4 degrees of freedom, and false. Double click. Still, we don't have any value for the negatives. Let's try degrees of freedom 10. And chi-square distribution, the statistic, the degrees of freedom 10, and cumulative false. And double click, and there you go. Now to give you a full view of the chi-square, I will just go and increment a bit more to the positive side, and let's see what happens. So I'll bring this down maybe until 8, and I'll just double click on each one of this, double click on this guy, and double click on this. Alright, it's quite nice. Maybe you can still go further, maybe 11. Alright, 11. So you just double click on that, on this, on this, and on that. The reason I said 11 because I see that there's still like quite a large percentage, like 7% in there. So maybe I can go 20. Oops, boom. There you go, 20, and same thing. Double clicking on each one of this, just to see what happens. Alright, that's 1%. It's good enough for me. And let's do a degrees of freedom of 30, which is, we can attribute that to a normal distribution, sample size of 30. Let's try this. Chi-square, some statistic x, degrees of freedom 30, and cumulative false. Press enter. Again, notice that there are no negative values whatsoever. Alright, our aim now is to plot this, and let's see what we get. So I'm going to highlight these things and press insert, and just this disconnected graphs right there. That is very nice indeed. Alright, let me just see through this. Alright, this is a chi-square distribution. Let me just move it right here so we can see. Alright, and remove the chart title. And we just do that. Chi-square distribution. And let's go and enlarge it so everybody can see it. Right there, chi-square distribution. And notice that let me just see if it's all correct. Alright, I was quite confused about this weird blue line right here, but I noticed it's series 5, that is our, let me just fix it for you so we can really see what's happening. Select data. Series 1 is the chi-square with degrees of freedom 1, and just call df1. This is with degrees of freedom 2, I believe, and this is with degrees of freedom 4, and this is with degrees of freedom 10, and this is with degrees of freedom 30. Alright, notice that the degrees of freedom 30, if I remove it, you would notice that this weird blue thing would just come out. Would be erased. So yeah, if I do that, you can see clearly what's happening. Let me just zoom it quite more so we can see what's happening in here. So here we go. The camera would only show to you a certain portion of the cumulative distribution, but you notice there's no value of it on the negative. It's one of the properties of cumulative distribution, no negative. And as you increase the degrees of freedom, notice that at lower degrees of freedom, its values would be bunching near the zero. And as you increase more degrees of freedom, meaning more samples taken, then the peak is gradually going to the right, But you can see that the peak also decreases. The probability of the peak happening is getting lesser and lesser as more degrees of freedom is happening. So we would use this distribution to calculate some statistic based on a chi-square test.